In our learning so far, we have used few IP addresses like 99.255.200.45, 192.168.1.5, 192.168.20.35, etc. Does that mean that anyone could use any IP addresses they want? Absolutely no. We know that the assignments of cell phone numbers or mobile numbers is controlled by the telecom service providers like Vodafone, AT&T, Geo, Horizon, etc. Similarly, IP addresses are controlled by a body called Internet Assigned Number Authority, INA. It's a standards organization that oversees global IP address allocation. This is not so important from a technical standpoint. What we should know is that the industry has come together to define several standards for the use of internet. One such standard is the classes of IP addresses. The entire range of possible IP addresses is 0.0.0.0 to 255.255.255.255. In total, we get around 4.3 billion IP addresses. These are divided into various classes, that is, class A through class E. The range of class A is from 1.0.0.0 to 126.255.255.255. Its default subnet mask is 255.0.0.0. It could provide us with 127 networks and 16 million hosts in each network. Class B range is from 128.0.0.0 to 191.255.255.255 with a default subnet mask of 255.255.0.0. Class B has 16,000 networks and 65,000 hosts in each network. Class C range is from 192.0.0.0 to 223.255.255.255 with a default subnet mask of 255.255.255.0. It gives us 2 million networks with 254 hosts in each network. Class D range is from 224.0.0.0 to 239.255.255.255. This range is reserved for multicast groups. Class E range is from 240.0.0.0 to 254.255.255.255 and is reserved for future use and research. You might notice we have missed a few IP addresses like 127.x.x.x, which is called as a loopback address, and 255.255.255.255, which is referred to as a broadcast address. We will talk more on loopback and broadcast IP addresses in the future. Let me share a piece of information that might surprise you. As we have just learned, there are around 4.3 billion available IP addresses. But we currently have more than 20 billion devices connected to the internet. How is this possible? The industry has achieved this by reusing the IP addresses. Now hold on. Wasn't it established that all IP addresses should be unique? Yes, that is correct. All devices should have a unique IP addresses. But if we give away all the IP addresses to individual devices in the world, we would have run out of IP addresses long ago. Then how did the industry sustain the internet? How can IP addresses be reused? There comes the concept of private IP addresses. Each class has a set of IP ranges that are called as private IP addresses. For class A, it is 10.0.0.0 to 10.255.255.255. And for class B, the private IP address range is 172.16.0.0 to 172.31.255.255. And for class C, it is 192.168.0.0 to 192.168.255.255. The specialty of these IP addresses is that they can be reused in different local networks. So if one set of IP addresses are called as private IP addresses, What do you think we should be calling the other set of IP addresses? You guessed it right. They are called as public IP addresses. Now let's take a closer look at how the IP addresses can be reused. Consider a house with maybe around 4 devices, a dorm or a hostel with around 50 devices, and an office building with 200 devices. When they request for an internet connection from an internet service provider, they have been assigned one public IP addresses each. Let's say the house gets 50.40.30.20, the dorm gets 60.50.40.30, and the office gets the public IP address of 70.60.50.40. But within the house, individual computers or network devices are assigned the private IP addresses like 192.168.1.2, 192.168.1.3, 1.4, and 1.5. Now let's take a look at the IP addresses assigned to the computers in the dorm. Here also the administrator could configure the devices to use 192.168.1.2, 1.3, and so on. If you look inside the office, the admin has decided to use the same set of private IP addresses, that is 192.168.1.2, 1.3, and so on. In the above network, we have connected more than 254 devices using just 3 public IP addresses. I know what you are thinking. How will internet understand which one is the real 192.168.1.2 or 1.3? Because there are so many of them. One should note that the internet does not care for private IP addresses. Think of the private IP addresses as a small baby whom we will not allow to go out of the house. Similarly, private IP addresses cannot go out in the internet. The internet does not understand private IP addresses. In other words, internet does not know how to route the private IP addresses. That's why they are also called as non-routable IP addresses. Let's say the mobile device in the house with the IP address of 192.168.1.3 is communicating with the server in the office with the IP address of 192.168.1.230. When this connection happens, as far as the internet is concerned, it only knows that IP address 50.40.30.20 is communicating to the IP address of 70.60.50.40. Then how does the mobile device in the house magically gets connected to the server in the office? That is possible with a concept called NAT, Network Address Translation, which is our next topic. But before we head there, let's conclude this lesson by understanding that a computer will have 2 IP addresses. A private IP address to communicate to the internal network and a public IP address to communicate to the internet. We have learned that IP config will give us the private IP address assigned to the computer. But in order to find out the public IP address that the computer is using, we should use the browser and visit the website whatsmyip.org. One should realize that the public IP addresses assigned to all the computers in a home or a dorm will be same. Now let's put this learning into action.